Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. And hello again to guys who are hanging out while I was just playing around with my Rubik's Cube. This is episode 46. This is the second part of the CPU fuzzing, stuff that I want to do. Last time, we mostly just set up a little test ROM, mostly by digging through the VBDE thing to find the parts of the scripts that we needed and get this little ROM going. Pretty nice, not doing much, but it does actually run in the emulator, which is pretty rad. So this should be pretty cool. By the way, hi to guys in the chat. Some of you I said hi to before, but I'll say it again anyway. Repnop, Daru2, Skeleton, Studio C, Metal Voids, Matt RVA, Mad Moose, Dark Second Kluash, George Morgan. How's it going? George Morgan, I have limited experience with embedded stuff, frankly. A lot of stuff with, like, I would say low-level hardware, but not modern embedded, if that makes sense. I don't do a lot of tiny Linuxes, for example. Matt RVA, have a quick question to Rush Boy. Why do you sleep the emulation loop for a constant 3 milliseconds? How did you come to that number? So you want to sleep for something. you want to at least have like 1 millisecond. I think actually 0 even will at least allow the OS to go and do some other things. The main thing is you don't want to take 100% CPU and just churn in that loop. So you want to do something. 3 milliseconds, honestly, it comes from, that's the timeout that I usually use when doing audio processing. It's kind of an arbitrary number, to be honest. I think sleeping for 1 millisecond would be just as effective in that case, actually. Would need to play with it. But yeah. So we set this up. There's actually a couple things I want to bring up before moving too much farther with some of this code. I'm gonna reformat it a bit to make it our own. The main thing here, a lot of this was basically copied from the VBDE thing, but it's just enough to get us a super basic ROM. Yeah, exactly, Skeleton. So what the goal here, I think I explained this last week, but I'll probably just keep explaining it because I think it's kind of cool. The goal here is to test the CPU a little more thoroughly. Particularly, I want to generate random streams of instructions, test that on both the hardware and in the emulator, and see if the results differ. Now, there's a lot of details about that I will be talking about as we kind of put this together. A lot of it I've already talked about, but that's sort of the general gist of it. So what we've done so far is made this test ROM, and I've done it in assembler so that we have full control over, like, what do the interrupt vectors look like, and that's mostly it, actually. Just so we have, like, perfect control over the environment so that the test is as isolated as possible, both on the hardware and in the Virtual Boy, and in Rush Boy. So we need to do a few more things with this ROM. We need to basically get it so that it can actually write out all the registers to the screen. I'm also going to be doing that in assembler. I don't think it'll be too bad, to be honest, as long as I can do InkBin and a couple other things, and this should actually go pretty well. I will need to pull up the other CRT0 thing from VBDE. And there's reasons for that. I think it was in, I don't remember where that was. I'll just pull up VBDE so we can get everything up in there. Skeleton says, when's the next Ferris doing whatevs, by the way? I don't know. The whatev stuff I usually just kind of do when I feel like it, or instead of something else. So I don't really know. I usually do the whenevs if, like, I don't feel like streaming something else. Like, so I've been doing that on Sundays a couple times. Or sometimes I just feel like it. So I usually announce that on Twitter. But yeah, I don't know. Where's VBDE? I try to keep a regular schedule with Sunday and Thursday doing demo scene and emulator stuff respectively. Beyond that, just play it by ear. So I think it's in here, yeah, in compiler. There's a couple important things we have to do. So one of the things I actually think is a really funny quirk of the Virtual Boy is you got to do this. You have to do, I don't remember the dummy SRAM reads here. But you have to, when the system starts up, the WRAM isn't actually ready. And so you have to do just a dummy wait loop where you do nothing. Just as long as you don't touch the WRAM, just to let it start up before you can actually use it. I think, of course, you can use it here. It's just that the behavior is undefined. So that's something we need to do. A lot of this we don't need to do, though. Like it sets up a bunch of sections and stuff that we just don't care about. Really not sure about what it's doing with these SRAM reads, but I'm going to skip those, to be honest. I think it's going to be okay. Yeah, like all this stuff we don't have to care about. A lot of these default register values. Some of these we will have to care about. We do want to know like where the stack's going to go, for example. So we'll have to copy some more of these things. But generally, it's not going to be too bad, I think. Isn't that much startup code to deal with. So after we deal with all that, then we can deal with, I want to do that, and then I want to get the thing actually printing some text on the screen in order to be able to print out the registers. And we'll sort of slowly build up this framework that we can inject blocks of code into. And those blocks of code are going to be randomly generated, and hopefully we'll be able to get that running today, but I'm not going to make any promises because I just don't know how long a lot of this stuff will take. But yeah. Cool, Metavoids. Which model is that? I had one of those when I went to college. I can't remember what model it was, and I wrote a raycaster for it in C. That's pretty fun. Most of those, I think, still to this day run Z80s. Maybe they don't anymore, but like 7 years ago they did. And that's pretty cool. Cool, Dark Second. Happy to hear it. I don't know how I helped last Sunday of that in that effort. Maybe just the inspiration. I don't know. FX9860. That might have been the one I had. That sounds really familiar. I legit think that's the same one I had, to be honest. At least it looks the same. I got it because it was kind of cheap. And I think even the dev kit I found was some GCC thing that was unofficial. Oh, I had the 9860 G2. That's what I had. Just looking at pictures. Wish I still had that thing. That's what it was, Dark Second. Yeah, cool. Yeah, a lot of it's just linking to that old the old CRT. Well, actually, you don't need to do that if we only do that for the synth, but yeah. So the one I had Casio Basic, but it's more fun to do it in C. Also, the raycaster I made was slow, by the way. It wasn't very good. It did like read, modify, write for every pixel, which is something that you can get around, I think. I think if I did it again, I would do it in like a frame buffer, because I was a raycaster, so I would actually try to do that in a sideways frame buffer, I think, and then have like a similar to the Amiga's chunky to planar to actually turn it into the horizontal image. I think that would be the way to do it if I did it now. Oh, really, Studio C? Were they worried about cheating or something? Because they're like, you need them in American universities. They make you buy them. Which is the only reason I had one, is because I had to. I did have a lot of fun with that thing, though. I think that's super weird that they would have banned them. Like, what else are you going to use? I don't like it when this stuff is aligned like that. I also don't know why this goes to R6. Maybe that's just a convention. I want to put it in R1 because I feel like it. And this was just a loop. Oh yeah, I bet Rebnop. Yeah, there's gaming. Pretty easy to get games for those, I guess. I don't know though. It's cool to have that kind of hardware around. Hey, did you know, Colin? Oh yeah, SDOC. I had a physics class that was like that. Like you could, he had a certain size of paper, and if you conformed to that, you could write anything you wanted on it. And he had the right to look at it to make sure you weren't cheating, because it was mostly for formulas. That class was mostly about like learning to convert between units and how to apply which formula. I kind of like that system, but at the same time, I don't remember any of those formulas, which I guess is kind of the right way to do it. Like, in the same way, I don't remember a lot of functions in a bunch of standard libraries, but I know when to use them and what to look for. So I guess he did his job. But yeah, we had graphing calculators all the time. And they were allowed. As long as I can remember, at least. That wasn't that long ago. That's funny, Repnop. I just realized I've been a lot worse at reading comments. Or reading the chat lately, so if I suddenly start doing that, it's because I meant to all along. So yes, we need to do this. I don't know what this is for. These SRAM reads. I'm gonna skip those. We're not gonna use SRAM anyway. Don't care about that stuff. I don't know why this is GCC 4.7. Disable, yeah. So this is gonna... This probably sets 2 bits to clear. No, this is definitely setting 1 bit into R1 here. Probably disable cache. Write something to this to clear it. Not really sure what this is doing. I want to actually disable the cache. It's not going to help us for the test we're doing. So I'm actually going to pull up the manual, see what these bits were, because I just don't remember. Plus, I'd rather get them from the official source than from the emulator, just in case. I think the architecture manual is what we want here. System register set. Exception status. Cache control. It also does SR5. What's SR5? I don't know what that is unless it's some other thing. 0 into SR5. Okay, so maybe it just stores that somewhere. It doesn't look like it, actually. It looks like this is a system register. Don't know what that's doing. It looks like you'd be writing to the program status word, which would make sense if you want to store 0 into that. That make a lot of sense to me. But I don't understand why that's... Maybe SR5 is just the name for that. Let's just try that. Actually, I can look that up. Or, well, I could disassemble this. Let's do that, actually. I'll write this down. I'm going to type this out myself just because. Do this, and then I can disassemble it in the emulator. Let's see what it is. We're loading R0 into that. Oh, I guess that's what this is. It probably writes to this to disable the cache, and then this is probably clears it, and this probably enables it. That's probably what this is doing here. Because the PSW, assuming the cache would be in here, which it might not be. I have no idea. At least you'd clear a lot of this interrupt stuff. It would enable interrupts as well. Which I kind of don't want to do at this point. But it wouldn't hurt since they just return. And if they... Yeah, so it might change some of the pending stuff. That might actually affect some things. But we'll see. Once we get the test bench set up, we'll see if the program status word starts becoming divergent pretty quickly. We can do that without actually running any other instructions. So we'll use that as sort of a litmus test. Studio C. That's intense. See you later, Repnop. Enjoy your COBOL. Said no one ever. Yeah, so here's the cache enable. And that is totally what it was doing with putting 2 into here, and putting 0 would just turn that off, I guess. We're just going to disable cache. We don't care about that. I'm just still surprised that this used SR5 and CHCW. Whatever. I'm actually going to run this in the emulator just as is. Let me pull up a terminal here. VB fuzzer. Make. No target specified in the make file. What? Oh yeah, see test ROM make. There we go. Now we got some junk at the end of the file. Ah, you know what it is? It's the comments. That's funny. C89. Or C89 style comments, I should say. That's fine. So now I have a test ROM. So I kind of want to do this where I make and cargo run. No, we'll do VBRS Rust Jewel Boy CLI target release Rust Jewel Boy CLI test ROM. Oops. .vb. No, this is build. There we go. And this looks correct. We're going to go to here we go. Yeah, so the SR5 was definitely PSW. Cool. At least there's C comments. I mean, it's using AS for the assembler, so wouldn't be surprised if we just have to use that. Anyway, this is pretty cool. Looks like it's working already. Happy about that. Now we are probably going to have to be a bit careful with some variables. Might even just be able to fit everything in the registers because there's so many. Which might actually do us a lot of favors in the case of this program because like some of the memory mapping stuff may not be very straightforward. But we'll see. I think this is kind of enough for this. Oh, the comments I was doing? I mean, so I've used assemblers that support those kind of comments. Back when I wrote my own assembler for the Game Boy and Super Nintendo stuff, I also just supported both. I supported the double dash, the seesaw comments, and the semicolon comments. It's common now, I guess. Maybe it didn't used to be. Let's call this end loop. I'm actually not sure what these underscores are. Should probably not use those, actually. Seems like there's a convention here to do these as like locals and these as globals. Whatever. Guess we'll do that. But yeah. At this point, we need to start setting up the hardware. Now, the nice part about this is we can basically port the code that I did for this ROM test. Yeah, shouldn't be too bad. A column table, that's going to be annoying. Did forget about that. Probably a nice way to set that up anyway, though. Yeah, assemblers have definitely evolved. Use a call table. I don't think there's a way to go there. I'm not sure where that would be, actually. It might be in video. Might not be. Could be a misc. Nope. I'm totally going to do an I2A thing today, by the way. Because we'll need that. So some of these top level things might be a little more annoying in assembler, but they're not going to be that bad, I think. By the way, I'm actually going to see if we can use PSW here. We can. That's more readable. But where would that column table thing be? Might be in this stuff. Nope. Even this calls it. Just CVB. Is there a car alarm going on outside? Yes. I don't know if you guys can hear that. Sorry if you can. I don't know where this is going to be or how to search in this, if we'll even get the right context. So I'm just going to go through all these and find it. Not going to take too long. That's cool. Sign lookup table. How do you install ripgrep? Can you do that via cargo? Because then I'd be much more likely to use it at least. Gotta represent. Oh, it is here. It is in video. Set call table. Totally gonna do that. Even though I already found it. So setting the column table is, as far as I know, just copying this. Oh, this is cute. But I guess it's because the column table has a bunch of mirrors. This actually makes sense. And we do need to set this. This is what actually stabilizes the displays, which is super annoying. This is something we have to deal with, frankly. But I think that's fine. By the way, I hate this stuff. Use the flags, Luke. All right, but I think I just need to do this. Oh, did I already have ripgrep installed? I probably did. Yeah, that's a good idea, Dino Colin. Especially for this stuff. How can I disassemble just with the GCC things that are here? Wait, the batch file that builds this actually totally had that. I should try that. Although I don't know if it'll give us assembly for all this. Ugh. Let's see. Yeah, OBJ-dump should be able to do that. In fact, you can do it for specific functions, which is really nice. So let's do that. Let's see if I can find the build files for these files. Let's see if I can pull that out of there, because that would be a little better. Tour says objdump.-d. In fact, we'll do this in the... Whoops. Oh, I keep doing that. Keep opening the remote desktop thing when I mean to open MSys. Yeah, I can use ripgrep to grep through the stuff that objdump uses. That's funny. Anyway, dev projects VB hardware tests reg scope is here, and I believe build might have the stuff in here. I mean, we really just need. So the VB thing's not gonna have it because that's just binary. Actually, I can dig through this here, see where this might be. Not giving me assets, components maybe. Oh, I hate this stuff that happens. But this will be good enough. Okay, that's actually great because then we can go through video here. This video object here. So we can do, actually we need that specific obj dump. That's going to be a bit annoying. Because we need, we need v810.132 bin v810 obj dump. Yeah, sorry about that. I legit forgot to set up the stuff for the console. That's not a problem. Sorry about that. There we go. All right, this is what we care about. So we'll do this, and then we'll do... Super jarring that when I Alt-Tab away from this happens. I don't know what that is. That's even worse. Nope. There we go. I hate that wiggle the window and all your stuff goes away. Who wants that? Anyway, let's see if we can do this just with... This is from test ROM. We'll do hardware test, reg scope, build, release, C. No, that's not what I wanted. Oh, actually it was, yeah. Use Ferris, downloads, VBDE, libs, libgcc VB, and somewhere in here we should be able to get video. .o. And now we need the arguments. Let's just see what happens if I do -d. Sweet. Oh, that's pretty. This is what we wanted. Very nice. So let's do, I think -f can do functions. Oh no, that's the file header. Executable sections using -d. I want to see if we can get a specific function. I don't know if we can do that though. We can get symbol tables with -t. That's actually awesome because like we want this, for example, and we want the column table. Display section of interest using -j. I should show what I'm digging through, by the way. Just digging through this thing I found. We want -j, and then I guess we have. So these are specific offsets within these. But I mean, that's probably enough if I just do. s-j.ro data. That is not what I wanted. I wanted disassembly of that. But if we do -d like this, do we get what we wanted? Yes, we do. Great. So this is the actual table. NM. I will do this. So we get our data. Which one did I do a second ago? It's T. Just this. Because we also had the do.text. And at least we get what we wanted out of here. This is good enough though. I can just sit here and format this by hand. That's not a problem. Assuming we get this, which is 1BC. So that's, I guess, here. Yeah, it looks right. Based on this offset. That's easy enough. And then, of course, this is also linked with the table in here. That's a bit unfortunate that we're not seeing the symbol there, because surely that would be available in the fix-ups at least, which is a bit annoying. But I think if we just compare the constants with the original, we can still save time by stealing this than writing it by hand. I think I'll do that, actually. So let's do this to get the column table data. And I'll just go in here and dump this out. We'll just do a bunch of dot bytes here. This was at the start. We can just do this stuff here because I don't really care. We'll do this as our column table. Yeah, I could also link with that. Assuming we set up the right stuff. It probably, yeah, we actually need to do some additional stuff here. I'll have to go through it and check all the registers too, just to make sure it's like we follow the right calling convention and stuff. Well, we'll see. This will be kind of just duct taping all this together, and that's fine. Because I don't plan on using much of this kind of code, just this thing here. We need to set up the stack and probably some other stuff. Get to that in a sec because I'm a little concerned with this. Let's do this. This will be kind of fun. And then we'll do this. Got an extra one in there. I think we'll do this. Probably need X's here. Yeah, exactly, tourist. Whoops. I know this may not be the fastest way to do some of this, but I don't really care. We'll get through it, and it'll be done. That's what matters. Look at that. Nothing to it. Whoops. I messed up. Nothing to it, he says. When there's something to it. Sweet. So there's our column table. That is packed. The column table, what that's doing is it's you write it to a big region in the video memory, and the hardware for the rotating displays will actually use that to calibrate. It's kind of cool. It is Studio C. In fact, you can do whole blocks this way, I think. Well, yeah, if you just do that, so it's super nice. This is what that's for, as far as I know. Okay, so we had. This was nice, though, to do this via OBJ dump. One thing that I really like about this toolchain, I've said this numerous times, but I'm just really happy about it, is that they did it by first just doing a patch set on top of GCC that just adds support for this architecture. And what I really like about that is you get it on GCC and, of course, the other bin utils. So you get to use all this how you like normally would when tearing this stuff apart, which is really, really useful. And then like the editor on top, yeah, that's whatever. I don't really care about that, but at least this is like general and I can use this, for example, for our purposes here. So I'm just really happy about that. Now we're going to have to do a few things with this one. First of all, that's where our column table loop is going to be. So I'm just going to put in that new line to make sure we don't miss it. Oh, and of course that happened. Okay, well, it's here. Do that instead. Good enough. I'm going to do this too because I just don't like this. And it'll get a little interesting when we start going through some of this stuff, but cross that bridge when we come to it. The other thing I actually like to do here, I like to indent my loops. Something like this. I like to have like the body of the loop indented, and then where like I would have put the braces not indented. Kind of like that. So jump to link pointer, we're not going to do. Yes, tourist, that's exactly what that was. He says as I delete it. Yeah, link pointer is R31, similar to ARM, from what I understand. So that's all that's doing. Yes, this clears R11. Clears enough of R12. So R10 here. I think this is all in the registers, actually. Except this stuff. So considering this address here, judging by where this is, I'm guessing R12 is the destination. Or no, because it's source destination, isn't it? So it makes way more sense if we're reading from here and storing to here, judging by the original code, which was reading from the column table. This column table is storing to this one. And we can even do, look at some of these offsets here. Isn't the most straightforward thing to do this way, but this is okay. The nice part about this is we have a debugger, even though it kind of sucks. This is interesting to me as well. Right here, which would make sense if this was counting down. Head one to R11. Is R11 used inside this loop? It's not. So I'm going to make this like this. I don't know why this is incrementing by 2 either. Maybe because this is indexed by 2, which would totally make sense because I'm seeing 128, 256, and 384, which is half of all these numbers. So that would make a lot of sense. So yeah, so R10 is definitely our column table here. And R12 is our column table here. So this just loads it with 0. Which is a bit weird. This is R14. That doesn't change either. Yeah, I don't think it does either, Daniel Colin. It doesn't seem to use any variables or the stack, which is good in our case. I still want to set up the stack as early as possible, but it's nice to know we probably don't have to worry about that here. So there's a couple interesting things here. So this together is making an address. I'm going to reorder some of these because I know that the ordering doesn't matter even with cache. Right, so here actually does decrement R12. Good catch, tourist. I guess what's weird about that is that it seems like it's going to decrement this. Because as far as I know, yeah. I also might flip some of this to make it simpler for me to understand. This stuff, what is R11? Where does that read from? R11, R14. Like I've seen this a lot in the disassembled code that it does negative offsets for these. So yeah, it's like it's decrementing the so it's kind of weird. Not sure what part you're talking about, tourist. About the part being in the loop. I'm pretty sure we got this right though. You think it's wrong? Go back. It's just indenting. Ah, yep, you're totally right. One off. Nice, good catch. That's what we need. Cool. I still think trying to adapt this code is going to save us time in the long run here. Skip some of this formatting just in case we mess something else up. Don't need this. This should work here. I'll do this. Yeah, so we have a right pointer here that's incrementing by 2 every time. That's all fine and good, although I might honestly flip some of these because this whole thing where it sets up an address with like a negative offset and then negatively indexes this. Oh, I do not like that. I see the compiler doing that all the time, and I don't really understand why it would want to do that, but that's fine. Also, I want to open this video.h. video C go? Just want to get these next to each other. There we go. Because, for example, the column table here, we want that address. You can also get this from the emulator, but I really like trying to get it from somewhere else just in case. Although this is saying it's just somewhere else. That seems a bit odd. I expect it to be linked from somewhere else. Maybe the VIP does it. Nope. Oops. I'll worry about that in a second. Because that was where the column table was going to be. And if these were flipped and this was the top of the column table, then we're going to want to do something different here. So I'm going to still move around a couple of these. Like, because you can see just by highlighting these where these are and aren't used. So we can start commenting some of these. So I think this is the column data read pointer is R12. Yeah, it's definitely what that is. And you know, when I look at this, I actually wonder if it's perhaps these instructions are the ones that get patched when it's gonna link everything. I actually wonder that, because it would make a lot of sense to have that here. This address -1, that would be. Oh no, that was here, wasn't it? Because this is loading from column table. So then I don't know what this is. Unless it was, oh, it's this one, isn't it? Of course it is. So here it loads. So like at this point, R11 is 0. I will do that to the locations. Yep, so I was right about that. These pointers are patched there. That makes a lot of sense. So yeah, the immediate value here is patched. The immediate value here is patched, and those are for the column table. In fact, I'm going to maybe move this back. Maybe I don't need to. Squeeze all that on screen. Yeah, this is the column table plus that offset. So that also makes a bit of sense. Also makes sense why we keep seeing these 0 values here, because that's what's going to end up getting patched. Okay, but anyway, in this case, we need this. That's what we need to satisfy. And then our 12. Our 12 should actually be fine if we leave this as is. And the reason is because this is going to read to, if I've read this correctly. No, that's not actually true. I'm wrong. Because this instruction here gets patched for the read pointer. Right. And then it's these ones. I think I'm wrong about this. I think these are all read pointers, actually. No. I'm wrong again. I'm going to put the order back for this so I can see this a little more clearly. I'll do that, and then I'll match up the relocks with this stuff here. Do this. Not the most straightforward way to do this, but it makes sense. Right, so then this one. In fact, I can just copy this. Because it's these immediates that are going to be patched. The immediate values on these instructions. So we'll want to fill these in, but it should actually just be a matter of using like these kinds of macros down here. In fact, by that logic, doing like low call table plus 0x7f, this might just work. This will just be a column table. This is going to be the high part of the column table. Now this S thing might actually be significant due to the way that this does signed ads when it does movie A, which is super annoying. But I don't think that'll be an issue. Yeah, might need to risk that. So yeah, this actually makes sense. If R11 and R12 are our read pointers and then R10 is our write pointer, then this being just a hard-coded address is actually fine because that will go to the right place. That's a fixed address in the hardware. So we wouldn't need to fix that. Let's just see if this builds. Oh, yeah, it doesn't like these comments. I don't want to delete them yet. I want to see this work first. Thanks for the help, by the way, guys. As I mentioned before, familiarity with these tools is not my strong suit. Invalid ROM size. Ha! How on earth did that happen? That's weird. Also, sorry for the Slack noises. Oh, wait, you guys aren't getting those because I don't have my... Never mind. Never mind. Yeah, this is an invalid ROM size. So I wonder... Why did this happen? Why did we get all this crap in here? Oh, that's why. Because I put the column table inside the vectors. Whoops. This is why assembler's fun, you guys. Okay. I don't think things blew up. So we made it to this loop here, which is great. So here it is. Here's just setting stuff up. So here's our WRAM wait loop. Here's our clear program status word and the cache. Here's our column table loop. And this should go to this one, which is also correct. These values look really good to me, by the way, in terms of patching that up. Here's our column table right after that. It's all nicely packed. Then we got a bunch of crap out here. But at the end of this branch will have our little wait loop at the end. This looks perfect. Progress. That makes me happy. Now I'm going to fix the formatting on this because it bugs me. Yeah, that was a nice idea to just steal that code from the disassembly. Actually, I will change a couple of the... Actually, I don't need to because they're documented here. So this is actually fine. Cool. Hey, Thrasher, this is a Sublime. You know, I just realized it's actually dumb of me to do this. To just jump here. Because I'm pretty sure there's a halt instruction that I just remembered because of this. And if I recall correctly, in fact, we'll even check the data sheet here. Where'd it go? Down there. Instruction set. If I remember correctly, halt will just sit there and wait. No, that's halt the processor. We don't want that. But there should be a wait for interrupt instruction. Maybe it's called wait. I don't know. I don't know why I can't search in these. We should actually use that. Not super important, but just while I'm thinking about it. We're in the... Did I miss it? I'm actually going to check this. I'm a bit curious now. There's VBRS. And in Russia Boy Core, in the V810, it is halted. Just something else. Might actually be what I'm thinking of. Anyway, not that important. We don't need to save battery while running these tests. It's the only reason I can actually think of that would matter. I'm still not entirely sure where our stack is going to be. Kind of want to know what this does for the stack. So it's 64 bytes away from the top of RAM. I wonder why 64 bytes. That seems weird. Maybe it's because it's only 64 bytes of stack. That's strange. Doesn't that seem small? Like really small? I mean, I guess it can move down below that because this is the starting point of the stack. What did it do with the stack? That is what it does. Also, I should look into these GP and TP registers, for example. I don't remember what those are. Might just be some temporary stuff, though, because it looks like it's reading from these. We're just setting up some variables, I guess. The boss key? What do you mean? What do you mean, Dur2? This also just seems to write this to a stack pointer. Oh, of course. I totally forgot. The stack pointer is totally a convention on this architecture. So we actually don't need to do that. It uses R3 to do that, and that's actually not something we need to worry about. I totally forgot about that. Yeah, the stack does go down, and that's the top of it. I still don't know why that's at the end of memory, like why they even have 64 bytes subtracted from that. Don't know. But it doesn't look like we need to care, actually. I totally forgot that was just a convention. So I'm not going to worry about that. And in that case, we can start actually setting up the video hardware. So we're going to want to more or less copy some more code I wrote earlier. Oops, close the build here. You know, I'm kind of tempted to do that again. Where we just assemble some code and then break it down. That worked out pretty well. Especially because we need to do things like set the brightness registers. Set all this stuff up. The other thing I'm going to want to do, actually, now that I think about it, we actually don't need to set up the column table either until after the test stuff, and I would rather not, just to keep that as isolated as possible. Because we only need to do it when we're going to enable the display, which we're actually going to do here. All this looks good to me. We're also going to want to clear the BG map. Set display, set up drawing. Yeah, let's do it. So the reason I wanted to have this in assembler is just to make sure that we had as much control over the environment as possible. Particularly, I want to know if we have like a consecutive block of memory, I want to know exactly where that is in memory that we can use for the generated code. I want to be able to have our own like complete control over these interrupt handlers because we're going to need to be able to override those at some point. So those are the reasons I wanted to do it in assembler. I just want to have total control over that. It makes it a little bit more annoying to do the actual drawing parts of this, but I don't think it'll be that bad once we get it all set up. Because this is also ROM, so we can't just overwrite this stuff later. Now, one thing I did just think of, though, that might make sense is... No, because to go the other way, we still need to set up a bunch of tables for the C runtime. Yeah, so I wanted to avoid C so we could, like, decide memory layout and stuff, too. Maybe it's not the best choice, but I still want to keep going with it. Oh, I know what you mean. now, Drew. That's funny. Yeah. Need a Twitch boss key. Yeah, that's actually a good point, though, Dana Colin. I wasn't really considering that maybe we don't actually need to set that much stuff up if we just do some functions. So, because then I actually kind of like going the other way. That is to do a couple of these functions in C, but then to do all of like our own startup here in assembler. I kind of like that idea. That would probably save us some time. That I like. Because this is the stuff I was concerned about, is having control over this stuff. So if we can still have control over this stuff and then do some of the other bits in C, I think I'd prefer that. In that case, I'd rather like move the column table and stuff also away from that. In fact, we can just do the rest of this in C in that case. Yeah, so I actually kind of like that. Let's try that. I think that's a good idea. Here's my fuzzer. So it shouldn't be too terribly difficult to link this stuff, especially because this already takes this output file. Now, I'm not that good at makefile macros, and I don't think it really matters here, because I think I'm just going to do hard code the one C file we have, because we're only just going to have one C file full of a bunch of functions, and then one assembler file full of the startup stuff, and then some other binary files as well, but that's all we need. And I think think that'll be easy enough to just throw together. There's also a lot of like headers and stuff here. I'm actually probably just going to copy the stuff we need out of the headers in order to make this stuff work and just put it on the top of our C file. And I think that's going to be okay. That makes it nice and easy, at least. Unless... yeah, I think that makes sense still. Because I'm still concerned about... well, actually, since we have the whole VBDE thing here, I can probably just link to the libgccvb files in there, like include those. Because I am still a bit concerned about that, but this will be fine. So let's do that then. I'm gonna rename these. Or maybe that's not so important here. Do this. A couple things here. That's going to stay the same. I don't think I would need to link anything else. I said link, I meant include. Just because like all the headers that define this stuff would be kind of nice to just include that, but I think we can just copy out what we need. Just seeing if I can get a way around that. Because I know that the way I want to like distribute this test ROM is that I want to have this in a repo where the VBDE stuff is a submodule in Git. And so if I can include stuff relative to those folders, then I think it'd be nice, but copying it would probably go faster today. So I want to call this something else. We'll do... I'll just call it ASM source. And the ASM object. I think that's nice, actually. We'll get the assembler object from the assembler source. Yeah, this reads fine. And then we can do the same thing here. In fact, we can even put these back. That's fine. No, we can't, actually, because of this. We'll get here. That's fine. Now here, no, we wanted the COBJ. And here we're going to need to do some other things here. Now the nice thing is I should still have all the stuff uncommented when building this. So it should just print all this out again. Especially because I actually changed like one line of this. So it should definitely build that at least. Thanks, Tourist. Yeah, I think we'll catch that when I find the command, which is this one. So I'm just going to copy this out, more or less. Yeah, so we need GCC. No worries, Tourist. Appreciate the help. do all the optimizations because that'll make it more likely to put stuff in registers. Or maybe not, but I like that idea. And then it has a bunch of include directives. I'm actually really enjoying using these tools for this. I think this was they're the right tools for the job. So, you know. Don't need to do like the end debug flags or anything because we're not going to be including anything. And yeah, we do need -c. Do -c on the source. I think that looks good. And then when we link, we build this elf file here. We need C object as a dependency, and I think we just add it here. Just looking at what else it did. Yeah, that should be all we need to do for that. Sick. And then as long as we play nice with the calling convention here, stuff should just work. That's pretty cool. Yeah, I probably should. I think we'll be okay just because of how it copies these sections. Well, we might need to do some stuff here where, for example, the other one here, the other startup thing here would need to jump into main. And so it should just... I expected it to have to say like extern main or something somewhere, but it doesn't even have to do that, it looks like, which is pretty cool. I'm not even going to call it main because that's not really what it is. Actually, I probably will. I think let's just do that here. Just jump into main. Something like that, and then do a new file here. And I think that might be enough. Oh yeah, well, true. Ha. That may have worked. Kind of unrecognized opcode. That's actually fine. Because it looks like it linked this main thing somewhere else. Oops. It's here, 9.8 here. So if we disassemble 10, for example, we just get a branch. There's not even a return because it knows the function doesn't return. Because this just jumps right to there, and then this is the whole function. Great. This looks really good. So now let's actually do that column table stuff here. In fact, we can even do it in other functions if we want. Yeah, this was a good call, by the way, didn't call it. I think this was the right way to do it. Because especially at this point, like, once we've done the tests, then I have no reason to care about the environment anymore. So I think this is good. There was some stuff in the linker script though, and I think actually in the as long as we don't use static variables. And maybe a couple other things. There might be some stuff we want to do from this again. Like, we don't need to clear BSS stuff. We can just assume it's undefined. This is for the data section. We might want to do that, actually. We'll see. Might not have to. These, I don't know what they are, though. Might want to do something there. I don't know what it's doing with this end stuff here. Reset when main returns. Nah, we're fine. We just loop. Or just assume it won't return is also fine. Heyo. That's the other thing I like about having this kind of control over this stuff is like we can just do stuff like this. Like main doesn't return and that's okay. Kind of have fun with it. So we do want to go back into video and set up this column table. The nice thing is this. We should be able to just straight up put this stuff in here. Might need some type stuff here. That's not getting types from here, is it? It is. Heyo. And then this is interesting because this has floating point stuff. Okay. And yeah, we can actually copy this, some of the stuff here. Yeah, I don't know what this was, but that looks batshit crazy. I'm actually going to get rid of that because that bugs me. Whatever that's trying to do, I don't want it to do that. We're going to need this. Don't know why that's extern. Let's copy all these. Probably going to need some other stuff. And then we can just copy this function here, which I'm going to keep as a separate function because that's nice. Yeah, so now it can't find this column table thing. Which is weird because it's extern here. I wonder where that was supposed to come from. I don't like that. But that would be a good time to rip grab. As long as I can get... I just want to know where this is. There it is. It might come from the linker script. I would think that was really weird, to be honest. I don't know where else it could come from. I just think it'd be really weird if it came from there. It's a bit odd. It could have been from their CRT0, which would also be weird. Not there. I wouldn't be surprised if it were here, but I just didn't see it in here. It's just weird, man. These two, like the L frame, R frame stuff. So like these are definitely constants, first of all. Yeah, it says that here, but like they're defined as part of the memory map, but just where does that come from? Anyway, I had the properties here, so I can go there and rip grip. Yeah, that's a good point, actually, if it might be in some C file. In fact, it might be in this C file. Yeah, okay. There it is. Good call. That's nice and easy. Yeah, I don't know why it's that way. Doesn't make that much sense to me. But not to worry. Because in our case, it's just going to be here anyway. BGM Embase it didn't have now. I didn't accidentally remove too many of these, did I? Oh, they need to be in the right order, of course. Ha! It ran. This is really cool. I'm enjoying this. So now we went to 6A here. Oops. Should have been here. Right, because now our like setup column table function is going to be down here. Oh yeah, that's also why that was offset before, because we had the column table in the startup routine. But now this is going to be tightly packed, which totally makes sense. Although I am seeing this. So it looks like we actually do need to set up the stack pointer. Because this is definitely pushing the link address onto the stack. That's what this is doing here. That's kind of funny. Yeah, this must be for our main function here, actually, because if you look at up here, it's going to go to 6.0. So that's actually here. Right, yeah, so this right here, this whole thing is pushing that on the stack. And then it calls the routine here, 1.8. Which is halfway through here. I guess this just didn't disassemble correctly here, honestly, because it looks like these FFs here are padding bytes. Then would have started here, so that could make sense. But in any case, that's going to be the function for the column table. And then here it jumps back. And then it just branches here. And then we have some crap at the end here, which I don't think is valid. This is probably column table data. Or something else. Who knows? It's at least deep, Alkama. But I like this. Other than the fact that R3 is just bogus right now, which we can totally fix. This looks like it's going to work. And that's sick, because that means we'll probably get this done a lot sooner. I think that's going to save us a lot of time. And it's going to make the parts where we just show graphics a lot more comfortable, which is definitely valuable in this case. Because, like I said, we have no reason to be too careful with our environment at that point. But yeah, let's set up that R3 thing. Now the interesting thing is that this other CRT0 here goes to stack pointer. I wonder if stack pointer is just an alias for this. Like, yeah, for example, LP is going to be our link pointer, so that's going to be R31. So it must be that these are like default values for these things. Now I'm guessing these just come from the linker script. So why don't I just copy this? We can do this here even. And what I like about that is then we still have super control over all this stuff. And then at the last minute, we can set up everything we need for C and just get in there. This is again, same thing. Sets up 7.8. 7.8 is down here, and it pushes that onto the stack, which is now okay, given the stack pointer. Oh, yeah, that's what I was going to check as well. Yeah, push that to the stack pointer, 3, 4, 5. Guys, this looks super good. This is totally the right way to do this, I think. Okay, so now, now the next step is background color. Let's do that, because that'll be nice and easy. Or we can just go for gold, because this stuff is not that complicated, although it was drawing specific things. So I think we'll do this. I think we'll set up all this stuff. What's this BG map? We'll set up all this. And just start including stuff that we need. And I think if I do this, then we'll get red. I think that's how that's going to work. This we need to not do right now. Let's see what we're missing. Lots of things. So VIP regs. I'm really satisfied with this, you guys. And again, looks like there's one of these. It's probably going to map with the stuff in here. Yep, there's the extra in there. Still don't know why it does that. Because especially when those are constants, it's just weird. But not a problem. Because we can just stick this here. And this we can replace with the actual definition. And then we need the world stuff, which is there a world.h&c? There indeed there is. So we'll just copy all this. We'll not worry about this yet. I think I was doing that by hand anyway. But I like having this struct. I think that's a good idea. Almost. Looks like the WA thing as well did something stupid. It was here. Oh yeah, this is the array into all the worlds. That's fine. We'll do this. Okay, we're moving. We didn't get all red. Yeah, that might actually be worth it, Dino Colin. Might do that. I keep disassembling all of this because I like to see it. Especially where it's jumping to. Just 7/8 here. There it goes and does the setup stuff. I should actually do function inlining, but for now it's kind of nice not to have it to set all this stuff up. Anyway, where were we? We're waiting on something. Which is kind of not what I wanted to see. Actually want to do this. This does exactly the same stuff. This does do background colors 3, which is what I should have put here. Did I even copy that part? Yeah, I did. That's here. Just as a test, though, I'm also going to do this. So it doesn't actually draw any worlds. Oh, but we totally didn't do this stuff. Set the display and everything. Oh no, we do. We actually do that here. Okay, a bit surprised this isn't working. I'm kind of curious about this actually. It's from C249. Makes pointer from integer without a cast. Yeah, let's cast that. I want to keep this in here. All this other code. Why not just put all of it in the header? In fact, I'll even put this together with the column table stuff. I think make can actually detect this stuff. But not to worry. Thanks, Alkama. Loyal ship hand or something. Something piratey. Get to know tourist. Then I'm going to do this. Because this is totally the kind of thing I would forget to do. So, and this is actually wrong because this was called stuff. So why wouldn't this work? Let's do this again. A little bit concerned about this, to be honest. I can't imagine why this wouldn't work. I agree, tourist. You know, you might be right, Dino Colin. We should actually do that just because the test ROM did. I would assume we wouldn't have to, but maybe the code doesn't make the same assumptions. It's not really up to us what it assumes. So let's actually try that, because it is something different that we're doing. So that's a good place to look. This might also do some stuff with the data section. Why don't we just grab this stuff? Grab all of it, including this stuff for the SRAM section, which I wouldn't have thought we needed. Maybe we do. Maybe we do. That was before this stuff, right? Yeah. In fact, that was... Let's even do this. We can just do this part twice where we clear the cache. I think that worked. Either this crashed or this is just what this looks like in my emulator, which I actually think is the case. In fact, if we go over here and just change this to 2, then we'll get less brightness and this should be gray. And it is. Good call. I don't know which part of that fixed it. Frankly, it doesn't matter because it works. That is cool. I think I'm considering stopping at this point because we still need to pull in a font and do some stuff for printing out registers. Was kind of hoping to get that done today, but I think it'll take more than 15 minutes, which is kind of my limit today. So I think I'll stop here, but I think this is a good stopping point as well. Pretty happy with the progress today, actually, considering how many little details this actually had. And also considering the fact that we ended up with this test ROM where we can still have this much control over all this stuff. And we get to do some more of this like boilerplatey stuff in C, which is really nice. I like that a lot. I like that a lot indeed. I think what I'm going to do is stuff this in a little private repo here. And the only reason I want to make it private is just so I don't have to worry about licensing and stuff yet. And I'll just ignore some of the stuff that I want to make submodules. Actually, I can just do that publicly, can't I? Actually, you know what? I'd rather just do it where I just, yeah, have it like this. And then just add everything else to a private repo. I made a lot of stuff in this like V810-132 thing. Yep, that's what I thought. A lot of this libc stuff that we just don't care about. But the advantage here is that I can just kind of continue to make a bit of a mess here. And then when I get ready to sort of publish this, then I can just do that. Somehow I changed my keyboard layout. There we go. Anyway, I'm just going to push this really quick. And then I think I'll call it a day. But yeah, I'm really satisfied with this. Thanks for the help, guys. Thank you for the help, guys. If I remember how to talk. And then next week we'll finish the drawing stuff, we'll get it to write out registers, and then we can start the actual fuzzing stuff. Nice one. Cool. All right, thanks again, guys. I'll head out, and I'll see you later.